Welcome to Zener Diodes review. All right, so let's say we want to find IRL and IR1 in IZ. Let's kind of break down the theory here. So let's call this R1 and this RL. Okay, so we're going to be given the voltage, the supply voltage. That's this voltage right here. Call it Vgen or V supply. We're going to probably be given a Zener voltage. It's going to be right here. Vz. Okay, so in order to know VR1, we're going to just write a Kirchhoff loop right here. So we can write that loop as minus Vgen plus VR1 plus Vz is equal to 0. Get our polarities for our resistor in here. So VR1 is equal to Vgen minus Vz. Now, if the R value is given, we can solve for IR1. It's going to be equal to VR1 divided by R1. That gives us IR1. Now, let's see if we can figure out what IRL is. So if we write a loop equation here, we know the polarities are here. Write another loop equation. We've got minus Vz plus VRL equals 0. So we can see that VRL is equal to Vz. So now we can find IRL. It's going to be equal to VRL divided by RL. So now that we've got IRL and IR1, we can find IZ. And we know that current flows, if we do negative to positive, like this. So we can write a loop equation. We can say that IR1 is equal to IZ plus IRL. So we can see that IZ is equal to IR1 minus IRL. So now we're looking for IZM. So if we look at IZM, we know that if we're given power of the Zener, so if we've got PZ is going to be equal to IZM, the maximum Zener current, times the Zener voltage. So IZM is going to be equal to PZ divided by VZ. Now let's look for RL min. So we know if we're looking for RL min, we're going to keep the circuit the exact same with the same voltage, and we're going to start dropping down the RL min. So that means that IRL is going to go up. It's going to go up. So the question is, how far up can IRL go before we lose regulation at the Zener? So we know what IR1 is. As long as we've got regulation, IR1 will remain the same. So the question is, how far up can IRL go before the Zener loses regulation? So the answer is we want to bring the Zener current to IZK. So IR1 is going to be equal to IZ plus IRL. So we know that now if IR1 stays the same, we want IRL to be equal to IR1 minus IZ, or in this case, IZK. And IZK would be the minimum Zener current that will keep the Zener regulated. So now if we've got IRL max, that's going to give us our max IRL. So now in order to find the RL min, we're going to divide VRL to get the RL min. So RL min is going to be equal to VRL, which is VZ. So VZ or VRL divided by IRL max, which is going to be the maximum current through the load, which is going to be IR1 minus IZK. All right, so let's look at Vmax. Now this is talking about the supply voltage. How far up can we bring that supply voltage before we damage the Zener? So we know that as long as the Zener is regulated, IRL is going to stay the same. So therefore, we know what IZM is. Now that we've got IZM, we know what the maximum current is going to be through R1, and then we can then multiply that and then Kirchhoff the voltage out and find out what the supply voltage max is going to be. So first let's find that current. So we know that we've got IRL is going to be VZ divided by RL. And then we want to add that current to IZM of the Zener. That's going to give us IR1. Now we can find VR1. And now we can Kirchhoff adding VR1 and VZ to get the generator or the supply voltage. And that's going to be our Vmax. So Vmax is equal to VR1 plus VR2. We've set our Zener to the maximum current. We add that IZM to VZ divided by RL, which is the IRL. Then we multiply that current by R1, that gives us VR1, and VR1 plus VZ is going to be Vmax. All right, so now let's look at our Vmin. Similar to the Vmax, and we're looking for the minimum supply voltage that will keep this Zener regulated. So we know that IRL is equal to VZ divided by RL. We want to add that to our IZK, our minimum Zener current to keep this thing regulated. And that's going to be equal to IR1. Now we can find VR1 is equal to IR1 times R1. Now that we've got VR1, we can find the Vmin is equal to VR1 plus VZ. So our V minimum, our minimum voltage at the supply is going to be equal to VR1 plus VZ, which is going to be equal to, our VR1 is equal to our IR1 times R1. Our IR1 is now our minimum Zener current plus our IRL.